if you have any questions. So let's look at your own first of the worksheet here. This is where your notes are. So this is 3-3. We're going to be graphing all types of quadratics. So when graphing a quadratic in Vertex form, it has this form, guys, and it says this on your paper. So it has this form, a times x minus h squared plus k. So isn't this where our shift is left and right? Everybody remember back to graphing these. This is our shift left and right. Then this is our shift up. Oh, and we always go opposite of that, right? So maybe write opposite to remind yourself. And then this is our shift up and down. And that stays the same. We'll go with the sign. And then this A won't affect anything other than if it's flipped upside down. If that A is negative, isn't that a frowny face? Negative people like to frown, you know what I mean? Smiley face, positive people like to smile. So these ones are the easiest. And then remember, I taught you a little trick, the 1, 3, 5, 7 rule, you know what I mean? So if your A value is 1, you just use 1, 3, 5, 7. And if it's greater than 1, you'll just multiply those by that value. So let's look at our first example here. Once again, this is not new to us, so let's graph this. So the first thing you do is determine the vertex. So you'll determine your shift left and right and up and down. So right here, we know it's going, since it's plus 2, we go opposite, right? So it's left 2, everybody. So I'm going to write that down. Right, left 2. Now our shift up and down is right here. The sign stays the same, so we'll be going up 4. So start at the origin, 0, 0, go left 2, and then up 4, and put your vertex. Now vertex is the highest or lowest point. So looking at this equation, just curious, is this a smiley face or frowny face? Looking in front. Smiley face. Yeah, good. It's positive 1 in front. So positive people like to smile, so we know it's an upward facing parabola. So then from there, let's draw in our axis of symmetry. We know it's going to be on through that vertex, and we know it's going to be symmetric around the axis of symmetry. So now we can use our little 1, 3, 5, 7 trick. Let's do that. So from the vertex, we're going over 1, up 1, over 1, up 1. Notice those are symmetric across the axis of symmetry. Now we're going, we've done that. We always go over 1. Now we're going to go up 3, up 1, 2, 3. So from that point, you're going over 1, up 1, 2, 3. Notice how those are symmetric. Now we don't need to keep going. We could go over 1, up 5, over 1, up 5, but that's off of the graph. I only care that you graph as much as you can on the graph. So now we can draw that in. Pretty easy, right? Everybody good with that? So now let's tell our domain. So our axis of symmetry, let's go through and answer these questions. Axis of symmetry is the x value. So x is equal to -2, right, everybody? And our vertex is at the point -2 up 4. Any questions on that? So domain is left and right. Where is your function in general going from left to right? So with a parabola, isn't it going like this forever? So negative infinity to positive infinity. Domain is left and right. It's going that way forever and that way forever. So our domain is negative infinity to positive infinity. Remember, infinity always gets parentheses. Our range is where's the lowest point on your graph to the highest point on your graph. So let's look. The lowest point on our graph is the y value of 4, correct? And then it's growing upwards, so it's growing up to positive infinity. So our range is 4 up to infinity. Now 4 gets a bracket because it's included. It started right at the value of 4, and it grew to positive infinity. Infinity always gets in parentheses. Questions up to there? So increasing and decreasing intervals. Remember, decreasing is when you're sliding downhill. If you were to physically step on it, would you be sliding downhill? Then it's decreasing. So let's do decreasing first. Because from left to right, if I stood on this one, I slide downhill. So we're decreasing from negative infinity, and it's x values. So we're decreasing from negative infinity up to what x value? -2. So that was decreasing. Negative infinity up to -2, parentheses. And then we're increasing after we hit that bottom at that x value. Now from that x value onwards, aren't we walking uphill if we were to step onto the graph and walk? So that'd be increasing. From -2 to positive infinity, we're now increasing. So pretty simple, because we've already learned it before, it's just review. Everybody feeling pretty good about this? We've got to ace this test. We've done tons of review. Okay, next problem. Let's do the next example here. So the first thing you do is say, is it in vertex form or standard form? This is in vertex form. So the first thing you do is determine your vertex. So you look at your shifts. That's -1. We always go opposite of what's in parentheses. So we're going to be going right 1. And then we'll be going up 3. Right? So start at the origin. Go right 1, up 3. Put your point. And let's draw in our axis of symmetry while we're there. So there's our vertex, our lowest or highest point. Once again, in front is a positive, so it's going to be a smiley face. Just keep that in mind. So it's going to look like this. And now we'll use our 1, 3, 5, 7 rule. There's nothing we need to multiply by. 1, 3, 5. So from our vertex, we're going over 1, up 1, over 1, up 1. We just did that. Now from that new point, over 1, up 1, 2, 3. From here, over 1, up 1, 2, 3. And that's all that needs to fit on our graph, so we're good. We can draw it in. Everybody feeling pretty good about this? Okay. Axis of symmetry was at x equals +1. Our vertex was at over 1, up 3, 1, 3. Domain is, where's your function going? From left to right. So isn't it, once again, negative infinity to positive infinity? You're going this way forever and this way forever. Okay, so domain negative infinity to positive infinity. Range is the lowest y value to the highest y value. So the lowest y value started at 3, right? Through to positive infinity. Range is y values. It included 3, so we got to put a bracket. Increasing intervals and decreasing. So notice we're decreasing first because we look at it like we read a book from left to right. So if we stood on this, we'd be going downhill until we hit that x value. So we are decreasing from negative infinity up to 1. And then we're increasing, we start walking uphill after 1. After the x value of 1, now we're walking uphill. So 1 to positive infinity. We're increasing. You guys feel pretty good about those? Okay, how about we let you do, I'm going to let you do 1 and 2 on your worksheet. So with the class practice, I'm going to give you a second to do 1 and 2, and then we'll come back and graph them in standard form. Check those off with me, and then we'll move on. Okay, so here's how we graph something. Now notice there's a notes page. Go to your back page of your notes page. So when graphing in quadratic and standard form, it's often easiest to put it into vertex form. I kind of changed my mind when I started doing it. I'm like, we could go all the way because we know how to complete the square and put it in vertex form. That's one way of doing it. But I'm like, we already know how to graph something in standard form, and that was just almost easiest for me. Like, we already know how to graph that. Why go through and complete the square when we know how to graph something like that? So I kind of changed my mind. So let's just go through it, because I think you'll think that's easier than going through all the way, putting it in vertex form. If we know how to graph it in standard form, why did we learn that? If you know what I mean. Does everybody agree? So let's go through and graph this in standard form. So do you guys see why it's in standard form? Because it's not in the form. It's in ax squared plus bx plus c form. Everybody? So it's not in that shifted form. So then remember, you can find the vertex by going, okay, so x equals negative b over 2 times a. That is the x value of the vertex. So you do have to remember that. But I really, truly, when I started doing them and completing the square, I'm like, this is so much harder than remembering that one thing. So a is 1, because that's in front of x squared. B is positive 8, so write that out. Does everybody see why b is positive 8, cx? And then c is positive 14. Okay, so let's find the x value of the vertex by plugging it into our formula here. So negative of b just means the opposite of b. So isn't this positive 8? Guys, so that's negative 8 over 2 times a, 2 times a. So a is 1. Now you remember there was one thing you have to do. You have to actually multiply the bottom out before you divide. So negative 8 divided by 2, correct? 2 times 1 is 2. So that's really -8, well, sorry, that's really -4, correct? So our vertex is -4 comma something. So does everybody kind of remembering, oh yeah, I remember us doing this a while back. So we know it's at -4, but we just don't know if it's up here or down here, correct? -4 comma something. So then can we find out what it is by plugging in -4 into the function here? Remember doing that? So let's do that. Now watch, this is really important. If we're gonna plug in, because this is x, y point, if we're gonna plug in -4, we've got to use parentheses. So that's right here. I'm gonna erase this real quick and do it underneath. You've got to use parentheses. So we're putting in a -4 wherever there's an x. So that's -4 squared. I've got to use parentheses. Plus 8 times -4. You've got to use parentheses plus 14. Does everybody see where I plugged it in? No confusion? Okay, so let's all type it into our calculator exactly like that. Or just calculate it without your calculator, like without a graphing calculator, you'd have to do -4 times -4. You have to calculate them individually, then add them up. So what do we get? You get -2? Awesome. So was everybody able to get -2? Because if you can't calculate it, you're going to get them all wrong. You know what I mean? Is everybody good? So now we can plot that. So here's our origin, 0, 0, where our vertex is at -4, -2. So there's our vertex. Is this a smiley face or frowny face? Look at the leading term. Isn't it +1? So it's a smiley face. So now remember, we need some more points here. Now that we found our vertex, we can draw in our axis of symmetry. And now from here, the 1, 3, 5, 7 rule still can work as long as, for these ones, it's a little different. For as long as your leading term is either +1 or -1. Because if it's +1, you just go over 1 up 1, over 1 up 3, you know? If it's negative, you go over 1 down 1, over 1 down. Otherwise, you would plot more points by other means. Calculator, does that make sense, everybody? Okay, so let's do this. Since this is +1, we can use the 1, 3, 5, 7 rule. So from here, we're going over 1 up 1, over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3. Is everybody good? So then we would draw it in, and then we could go through and answer our questions. But now if you can answer the questions on the others about domain, range, axis of symmetry, you can do that on these. So I don't want to go through that and waste your time. I'd rather give you more class time. If you want me to keep going through that, it's really up to you guys. Do you understand all that stuff, domain and range, vertex, axis of symmetry, we're all good? Okay, let's do another one like that. So let's do this next example here. So we're going to graph it, it's in standard form. So you'd say, okay, I remember the vertex formula in standard form is the x value is -b over 2 times a. So you'd list out what a is. A, and remember it's in the form ax squared plus bx plus c. So our a value is +1. My b value is -4. My c value is +6. So let's plug in what we know correctly. You've got to do it correctly. So -b really just means opposite of b. Isn't it already negative? So it's going to be +4 on top, because the opposite of -4. All over 2 times a is 1. So we have 4 divided by 2, which is 2. So our vertex is at 2 comma something. So we'll plug 2 into our function. So that'll be 2 squared minus 4 times 2 plus 6. Calculate that, and let's see what we get for the y value. Okay. So that means we start at the origin, 0, 0. We're going over 2 up 2. There's our vertex. We put in our axis of symmetry. Now, once again, our leading term is +1, so let's use the 1, 3, 5, 7 rule. So from here, you can go over 1 up 1, over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3. That's good enough. So we can draw in our parabola. Everybody feeling pretty good about that? Let's just go to this last example, then I'll let you just work because it's a little different for a reason. So skip down, skip the next example. We're on our last example there. So notice the negative in front. So is it just going to be a frowny face? Negative people like to frown. That's what flips it upside down, you know what I mean? So let's go through this real quick. Once again, it's in standard form, ax squared plus bx plus c. So a is -1 in this one, b is -4, and c is -5. So you'd say in vertex form, the way to graph it is to figure out the vertex using the formula -b over 2 times a. So -b means opposite of b. So negative +4, right, opposite of b, over 2 times a, which is -1. So we have this so far. So we have 4 over, you've got to multiply that out. Down here, that's -2. So don't we get -2 in this one? So our vertex is at -2 comma something. So we'll plug in -2. You've got to use parentheses. This is the hardest one to plug in correctly because there's a lot of negative signs. So pay attention to what I'm about to say here. So when we plug it in, you're replacing x with -2. So careful because a lot of people miss this. You see how that negative in front? It has nothing to do with x. So we have to have that negative still. Now we're plugging in, instead of x, -2 squared. Do you see how you have to be really careful not to mess that up? Okay, awesome. -4 times -2 minus 5. If you write that out and then use parentheses just like this in your calculator, you should be good. So let's quickly calculate that. We're very thankful for Grace for calculating every single one of these for all of us, okay? So -2, -1. So now we'll go to the origin 0, 0, and we'll go to -2, -1. There's our vertex. Now we'll graph our axis of symmetry. And then we know it's -1 in front. So we've got to go, we're still going to use the 1, 3, 5, 7 rule, but we've just got to go over 1, down 1. So instead of going up, we're going down, which makes sense because it's up round. Over 1, down 1, over 1, down 1, over 1, down 1, 2, 3, over 1, down 1, 2, 3. So I'm using the 1, 3, 5, 7 pattern that happens with parabolas. So let's make sure with this one, maybe we should just go through the domain and range and increasing and decreasing at least on this one, because that's what tends to throw people off on this one. So domain is left and right. Isn't it still going that way forever and that way forever? So still -infinity to +infinity. Our range is where people get lost. Range is the lowest y value to the highest y value on the graph. Isn't my lowest y value -infinity? And then where's the lowest y value that stops? At y equals -1, correct? Parenthesis, -1 gets a bracket because it includes -1. So do you see -1 to -infinity? It makes sense for range. Then increasing and decreasing. Okay, increasing. Now careful because this one's different because aren't we, if we step on this, won't we be increasing first and walking uphill? So we're increasing from -infinity up to the x value of -2. So we're increasing from -infinity up to -2. Increasing and decreasing always get parentheses. Once again, just a reminder. Then decreasing. Now we're decreasing after we step off the hill. We're decreasing, but it's x values. So we're decreasing from -2 to +infinity. Okay, just making sure that we're all good with that, because that one is a little different. Okay, I'm going to let you practice, and now you can get one-on-one individual help. So you can go to your practice worksheet, start doing those, get help, finish that off.